Hi and welcome on the PowerConnect webinar. Today we are going to show you simple and fast connection design. My name is Dorothy de Pauw. I'm a sales manager at BuildSoft. And the example that we are going to show you today is this hinged beam to column flange connection. Now, first some background information about our company. Our company is BuildSoft, and we have over 2,000 customers in more than 50 different countries. We have over 25 years of experience in structural design analysis and design codes such as Eurocodes and American Code. Our 2,000 plus customers have over 4,000 licenses in use, and 75% of our customers, our Diamonds customers, which is our other software, have an active maintenance or subscription contract, meaning that they are active users and that they are happy with our support service and our new releases and trainings. We also offer educational licenses, which are free licenses, and we have over 2,000 student and teacher registrations every year. Now about the PowerConnect, which is this webinar is all about, of course. Now the PowerConnect is an easy-to-use steel connection design software. And we provide analysis and design of moment connections, shear connections, column-based connections, tubular connections. We support different design codes, Eurocode, Indian code, American code, and of course different languages. So this is Dutch, German, French, English, of course, Spanish, Chinese, Portuguese, Polish. Here are some examples of moment connections and shear connections, and finally tubular connections, which you can calculate and design with the PowerConnect. Now, going back to our example, this is what we are going to calculate, and the aim is that our beam should be an IP 360 with a length of 7.5 meters and a slope of 12 degrees. We will use bolts diameter 20 millimeters, and we have welds of 6 millimeters. The column will be an HAA profile 300, and we want to take on 200 kilonewton meters bending moment. So this will be the applied moment. We will have a shear force of 147 and a normal force of 138. Now, let's go to the PowerConnect. I'm going to open the PowerConnect, and we are currently in the startup screen. Now, the first thing you need to do is choose the correct connection type from the library. As you can see, we support the different design codes, Indian code, American code, but of course today we will work on Eurocode. Now for this example, we are dealing with a moment connection. So it's not a shear connection, it's not a tubular connection, only a moment connection. And the connection will be a beam, bolted beam to column flange with an end plate. And this is really the first connection in the upper left corner. So I'm going to select it and I'm going to click OK. Now, in the second step, you need to choose the cross sections, the material, and the bolts. Now, let's first assume that this connection comes from a braced frame. Yes. The proposed material by PowerConnect is default steel quality, which is just fine. The column cross section shouldn't be HA 200 but 300, so I'm going to open the library. I'm going to choose an HA 300. Okay. Now for the beam, I'm going to open the library, and we are going to choose an IPE 330. The length of the beam is 7.5 meters, 7,500 millimeters. And the slope is 12 degrees. Now for the welds, we have chosen 6 millimeters. Now this welds really means the throw thickness of the weld. So the 6 millimeters. Now let's go on to the bolts. The bolts are default in PowerConnect M20, meaning a diameter of 20, which is okay, and steel grade of 8.8, which is also just fine. Now these two parameters, let's not worry too much about those. And finally, we have to enter the thickness and the width of the end plate. Now, as you can see, there are no numeric values over here. There's some kind of letter codes that are used, CF, CB. These are really references to other dimensions in the model. And you can visualize these by clicking the little BH button over here. And you can see a little drawing. And on this drawing, you will see, for example, the CF over here. So CF really is a reference to another dimension. In this case, the dimension is the thickness of the column flange, which is not a bad choice to start with. The CB is also a reference to another dimension, in this case being the width of the column flange. Now, both are very logical choices to start out with. Of course, if you like to use something else, for example, 15 millimeters, that is of course no problem. Or if you prefer 2 times CF, that is also possible. So I'm just going to go ahead with these values. Do not worry too much about these values because you can modify the connection at any point in time in the geometry. So let's click OK, and PowerConnect will make me a 3D model of the connection. This is shown in the geometry window. I'll maximize this one, and here is our current connection. Now we can zoom in and out, of course, with the scroll wheel of the mouse, which is, I think, very known to everybody. And then in order to rotate the model, you have the scroll bars at the bottom side on the right hand side. Now if you take the little square over here, you can start moving the connection around like that. If you prefer doing it completely with the mouse, that is not a problem at all. You just hit the shift button together with the scroll wheel of the mouse, and then you have a 3D orbit function to move the connection all around. Now it's possible that you maybe do not like the black background. No problem at all. If you click just anywhere, just not on the connection, but anywhere but the connection, with the right mouse button, you can change the background color. For example, I'm going to white. And you can also choose the perspective. This is already now an isometric view, but if you prefer a perspective view like that, it's also quite pleasant to see. So what else can we do over here in the geometry window? Well, except from playing around with the background color and perspective view, the fun thing about PowerConnect is that you really can double click anything. So for example, I'm just going to double click the welds. And here we see indeed the throw thickness of the welds for the beam and the flange are set to the 6 millimeters that I have entered in the first window. Yes. We can also double click the beam, and what we see over here, of course, the section of the beam, the cross section, the details of the cross section, the material. Now I have noticed I have made a little error. This should be a 360 instead of a 330, so I'm going to open the library and I'm going to choose a 360 and we say OK, and the drawing, the geometry is immediately updated. We can also take a look at the beam. This is of course the cross section, details of the cross section, the material, and we have another tab page which is called technical, and here we can choose, for example, the cross section orientation for the strong axis or the weak axis. Finally, over here we can double click the bolts. I'm just going to make this window a little bit bigger. What we have over here, we have the option to add bolt rows, remove bolt rows, or optimize. There are two possible optimizations of the bolts. We have the general optimization, and PowerConnect will try to place the top bolt row as high as possible, as close as possible to the upper flange, taking into account Eurocode regulations, of course. And in the next step, PowerConnect will try to make these interdistances between bolt row 1 and 2 and 2 and 3 equal, so that they are evenly distributed in the interdistances. We have also the minimum optimization, and then PowerConnect will try to place all bolt rows as high as possible, except for the lower one, of course, which is always necessary for the compression zone. If you do not prefer to use these two buttons, you can always move around the bolts manually. We have an option here to move them horizontally. And if you like, you can move all the bolt rows together. Or you can enter a value like 50, and PowerConnect will jump to that place, to that location. Here I'm going to choose right now simple basic optimization. Last button over here in the window are the details of the bolts. So we have chosen an M20 bolt, but you can choose any other bolt from the bolts library. Here are all the dimensions and the steel grade, and you can choose, of course, other steel grades. Cancel, and we say OK. Now finally, here in this window, you can also add things. By add things, I mean add stiffening elements. So for example, let's click once on the column, and when you hit right now the right mouse button, you can add, for example, a backing plate, a web plate, stiffeners. Let's add a simple web plate. And as you can see, this web plate is added immediately. So there is no need to enter first the thickness and the height and the length and the width and whatever, and the material quality. No. This element is added immediately. Of course, as any other element in this geometry, you can double click it and you can start editing it. So for example, you can choose if this web plate should be single or double at the rear or at the front side. And the thickness of this element is CW. As CW, as you may have guessed already, is again a reference to another dimension in the model. So the CW corresponds with the thickness of the column web, which is, of course, again, a logical choice. Okay. Now, for the further continuation of our example, I will not need the column, the web plate anymore, so I'm going to remove it. Now, let's see what this current connection can take on. So I'm going to ask PowerConnect to calculate the moment resistance. Now you may think, we did not enter any loads. Is this possible? Yes, of course. PowerConnect does not need the loading on your connection in order to calculate the resistance of the connection. So if you want to calculate it, we just hit the little calculator and we let PowerConnect do its job. And what we see over here, well, there's a moment calculated, a normal force, and a shear force. So currently we have a maximum positive moment of 84.3 kilonewton meters. We have, of course, an applied moment of 0. And also, of course, the welds are calculated, and the welds have a resistance of 160. We have a maximum tensile force, compression force, and we have a maximum shear force. Now, in our example, in our PowerPoint presentation, we had some moments, some shear forces that we have required for this connection. So we have 200 for the moment, 147 for the shear force, and 138 for the normal force. Now, let's add these loads into PowerConnect. I'm going to the loads window right now. Just do a little zoom. Let's place it here in the center. And I'm going to add these loads to the beam, of course. I'm just going to click the little number 3. I'm going to add the loads, which is 108, 200, and 147. Okay. Now, I think it's more than obvious that the current connection will not be able to take on these loads because we only had a bending moment resistance of 83, 84 kilonewton meters, so that won't work with the current connection. So what I'm going to do, I'm going to return to the geometry and I'm going to add an element, and in this case I'm going to add a haunch. So I'm selecting the beam, click once with the right mouse button, and I'm going to add a lower haunch. Okay. Now, as you can see, again, this element is added immediately. I did not have to enter thickness, height, length, width, whatever. If we double click it, we can see the details, and we see that the length and the height is again determined by using references. The BH, so the height is BH, which is the height of the beam. So the height of our haunch is equal to the beam height. The length of the haunch is 3 times the beam height. Okay. Going back to the bolts, I'm going to double click the bolts. I'm going to add some bolt rows. So they are now all put in one place, one over the other. That's not a good situation. Let us choose optimal bolt position. Now they are nicely distributed over the end plate. I'll say OK. And now we can calculate the connection again. And what we see right now is that our resisting moment is 230.9, so 231 really, compared to the 200. So at this time, our connection can take on the required forces, and the connection is sufficient. Of course, the welds have become more stronger too because there are more welds, and this is not a problem for the welds neither. For the moment, for the normal force, everything is okay over here. If something would not be okay over here, you would see it appearing in red. So if a red text it means that there is an element that is not complying. It is not, it's not strong enough. Now, of course, we need to combine the normal force together with the moment force, and then we see that if we make a little combining formula, combining the two forces, that is the applied moment divided by the resisting moment plus the applied normal force divided by the resisting normal force, should be less than 1. We are at 0.96, or we are at 96%. That means that 96% of our connection capacity is used by our current loads, which is still smaller than 1, still smaller than 100%. So it's okay. Concerning the shear force, well, everything seems to be okay on the shear force side. Then we have also a stiffness calculation. So according to Eurocode, PowerConnect will calculate the stiffness and will also make a classification of the stiffness. So the current connection is considered as a rigid connection. Together with the stiffness calculation, we have a rigidity graph. So you can see over here, normally until 2/3 of the resisting moments, you can use the SJ stiffness. Afterwards, you need to use the SJ stiffness. What else can we get over here from the PowerConnect? Well, we have a complete list with all the data. So we have, I will probably try to push the scale to be a little bit bigger like that. Yes, let me see, with welds and with all the data. I'm just going to maximize this. So we have the column, all the column data with a little drawing of the column. We have the beam, the end plate, and the lower haunch, and of course the general material data. Then we have also some views and plans of the connection. Let me magnify this, put it on a little bit bigger like that. And we are going to zoom out a little bit. I'm going to ask the top view and a left view from the connection. And all this information, all these data, you can ask them also in a report. So that is what we are going to do right now. We are going to make a calculation report of this connection. So here we have three possibilities. Either you only want a preview of the report, or maybe you want to print a report, or you may want to send the report to an RTF format. RTF is rich text format, and you can open this in like Microsoft Word. Let's go for the preview. I'm going to ask some project data. So here you can enter the project reference, my first connection engineer, the engineer. Okay. Then in the second step, you can add the summary drawings, which are these little drawings, these little views on the connection, and you can set a scale in relation to the paper format. So in this case, I'm going to use 1:9. Okay. In the next step, we can show the loads. So I'm going to show all the loads information. Well, if you would have entered multiple load combinations, we could choose over here. Then we have the results. We will ask simply the major results and the result summary. And then the element info, I will ask to show all the element info. So these are the data and the drawings that you see in the back of the screen over here. So yes, all the data, and yes, all the drawings. And then for each element, you can set a proper scale. For maybe the lower haunch, I set it to 1:10, for example, which is a different scale. Okay. And then for connection view, you could choose to show some views of the connection. Let's not do that. I'm just going to ask a preview of what we have right now. So we have the project reference, my first connection, the engineer, the connection analysis. And then we have all the data, the haunch, material data. Oh, I think I've missed something. Let me go back over here. Did we include loads? Yes. Okay. Oh. Okay. Close. And finally, we can export these data to a CAD software. So I'm going to open CAD software. Next. Okay. And I'm going to export this data. I'm going to save the drawing to DXF. And I'm going to export, for example, all parts, but you could export a complete node or a 2D node or just one part. Okay, export all parts. My connection parts. I'm going to save this file on the desktop. And now I'm going to open this, open my connection parts, open, okay. And here we have an overview of all the elements in the connection. So this is the beam, the column, the column, the beam, the end plate with all the bolts, with all the bolt information, and the lower haunch information. Okay. So going back to our PowerConnect model right now, well, we have shown you in the past 30 minutes that you can design in a very simple and fast way with PowerConnect your beam column connections. You can add stiffening elements. You can play around with the bolt diameters, with the bolt positions, with the end plate dimensions, and every element in this connection is being calculated and being verified. So this means the column, the beam, the haunch, the bolts, the welds, the end plate, everything is checked. And it only takes a few minutes to set up this kind of connection. So if you want to play around yourself with the PowerConnect, feel free. You can register at www.buildsoft.eu/free trial for a free 30-day trial of the PowerConnect. And if you would have any questions about the software, feel free to contact us. We are always happy and ready to help you out.